Let's take a look at this problem. We need to find two values in this problem. The first one is the p-value, the other one is critical value. They are two different things. To find p-value, it depends on the test statistic, and critical value depends on alpha. Now, we begin with the p-value. First of all, please do note that this one is a two-tailed test. And how do we know two-tailed? Because of the not equal sign. When we test P, which means proportion, it will be Z statistic. When you have Z statistic, that means you have standard normal distribution. I would like to mark negative 1.66 on the my graph, negative 1.66. And this is a two-tailed test. To find the p-value, we need to find this little tail area and double it twice of this area. That will be the p-value. So keep in mind that this is the graph that we draw. We need to find the area to the left of negative 1.66 and double it. You could either use the table or you could use the StatsCrunch. I personally prefer just the StatsCrunch. Okay, it takes a little while. So now I go to the normal distribution calculator. It says negative 1.66, right? Now that's what I have. 0.0485. If you can see, this is the area to the. Actually, we just need to keep 4 decimals. So 0.0485 run to 0.0485, and you double it to get the p-value. So which means 0.097, right? 0.097 and 0. So this is how to find p-value for the critical value. Let's look at the critical value. It depends on the alpha. Now again, this is a two-tailed test. So when I draw my bell-shaped curve for the standard normal distribution, I need to split this alpha into two equal size. So which means 0.05. You just divide it by 2, right? And again, two-tailed test, you'll have two critical values. Each critical value corresponds to these two areas. So we need to find these two. And you just need to find one because they're symmetrical with respect to 0. Keep in mind that 0.05 is what we use to find this value. Okay, again, I would like to use my this guy. Just type in 0.05. Which turns out to be negative 1.64. Okay. With that, I'm gonna go back to my negative 1.64, comma, and 1.64. Like I said, we should have 2, and they're symmetrical with respect to each other. So this is it for the this problem.